Determination of minimum bactericidal concentration. This is a continuation of the last practical of determination of minimum inhibitory concentration of antibiotic. This is determination of minimum bactericidal concentration of streptomycin. So it is also called as MBC. MBC, it is determined following MIC. So the definition of MBC is it is the lowest concentration of antibiotic required for the complete killing of the indicator microorganism under test under standard experimental conditions. So remember the difference. Minimum inhibitory concentration, it measures the lowest concentration of antibiotic that is required for inhibition of bacterial growth. So this inhibition, it may be a temporary inhibition for definite period of time, and these bacteria which are inhibited, they may start growing thereafter. So there is no complete killing. The metabolic activities are inhibited, and in case of bactericidal concentration, means this is the lowest concentration of antibiotic that permanently kills or destroy the metabolic activities of that indicator bacterium. The requirements for this practical are the tubes from MIC set showing the absence of turbidity, and second, sterile nutrient agar plate. The procedure is simple. The procedure is streak a loopful of solution from above mentioned tubes, that means the tubes which showed absence of turbidity, and these solutions are streaked on sterile nutrient agar plate separately. Then these plates are incubated at 37 degrees Celsius for 24 hours, and followed by that these plates are observed for the presence or absence of growth. Now, determination of minimum bactericidal concentration. This will be after the determination of MIC. So look at the earlier set of MIC in which the results were presence of turbidity from tube number 1 to 7, absence of turbidity from tube number 8 onwards, presence of turbidity in turbidity control. So here we'll choose the tubes showing absence of growth, that is tube number 8, tube number 9 and tube number 10. That means tube number 7 is the last tube showing presence of turbidity. So we have to choose 3 or 2 tubes next to the 7 tube showing absence of turbidity. So a loopful of suspension from 8 tube is spotted onto nutrient agar plate, 9 tube is again spotted onto nutrient agar plate, and 10 tube spotted onto nutrient agar plate. This protocol is followed just to determine the presence of live organisms in tube number 8, 9 and 10. In earlier analysis, we have determined minimum inhibitory concentration. That means the concentration required to inhibit the growth. In this analysis of minimum bactericidal concentration, as the word indicates, bactericidal, that means the concentration required to kill the indicator organism. So inhibition, it can be temporary, but bactericidal concentration is a concentration of antibiotic that kills the organism. Therefore, this analysis is done. So this plate is then incubated at desirable temperature for 24 hours, and if the results are like this, in the zone of 8 there is presence of growth, in zone of 9 and 10 there is absence of growth. This means that the minimum bacterial concentration is more than 8 and less than 9. That is because in between a range of 8 and 9, again there will be sub concentrations of 8.1, 8.2, 8.3, so on and so forth, 8.9 and 9. So it will be reported as MIC of streptomycin lies between, sorry, MBC of streptomycin lies between 8 and 9, or MBC is more than 8 and less than 9. These types of calculations or information is very useful for the viva as well as for the spotting purpose. For spotting, there can be there may be a set of tubes indicating, and you will be asked to determine the value of MIC just by looking at the turbidity of tube.
The final result will be written as the minimum bactericidal concentration of streptomycin is more than 8 micrograms per ml and less than 9 micrograms per ml for Staphylococcus aureus. That means the minimum bactericidal concentration of streptomycin lies between 8 to 9 micrograms per ml for Staphylococcus aureus. This means that if you consider the range of 8 to 9, it means that the minimum bactericidal concentration may be from 8.1 to 9 micrograms per ml, and therefore further we need to perform the assay between, that is determination of MIC between 8 to 9, considering the concentrations of 8.1 to 9, 8.1, 8.2, 8.3, so on and so forth up to 9. And further, after getting the results, further you'll transfer those positive tubes to the nutrient agar plate.